Let's look at how these functions look graphed. Consider the functions f of x equals 2 to the x and g of x equals 3 to the x. Fill in the tables below to graph these functions. So for figuring out f of x equals 2 to the x, this first would be 2 to the negative 3 when you plug in x is 3. Remember that whenever you have negative exponents, you can rewrite them as positive exponents by putting them in the denominator. So that's the same thing as 1 over 2 cubed, which is 1 over 8. When x is negative 2, we get 2 to the negative 2, which is 1 over 2 squared, which is 1/4. 2 to the negative 1 is 1 over 2. 2 to the 0 is just 1. 2 to the 1 is 2, and 2 to the 2 is 4. So when I go to graph these, I get negative 3, 1/8, negative 2, 1/4, negative 1, 1/2, 0, 1, 1, 2, and 2, 4. Okay, now let's graph g of x. So g of x was 3 to the x power. So when x is negative 3, we get 3 to the negative 3, which is 1 over 3 cubed, which is 1 over 27. 3 to the negative 2 is 1 over 3 squared, which is 1/9. 3 to the negative 1 is 1/3. 3 to the 0 is 1. 3 to the 1 is 3. And 3 squared is 9. When I go to graph these, we get, so negative 3, negative 1 over 27, 1/9, 1, 1/3, 0, 1, 1, 3, and 3, 9, or 2, 9. Can y ever equal 0? Why or why not? So y equaling 0 would mean that we would get 0 equals 2 to the x. Is there an x value that when I plug in, or is there an x value so that when I plug it in, 2 to that power is going to give us 0? And the answer to that is no, because 2 to any power is never going to equal 0. 2 to the 0 power is 1, because anything to the 0 power is 1. We will never be able to get 0. So y equals 0 can never be a point. Notice that both of these functions are increasing as x increases. So what does this mean? So this means as your x values are getting larger, your y values are also getting larger, and you can see that in both of these graphs. Which one is increasing faster? We can see that the g of x function, which is 3 to the x, is increasing at a faster rate. And that's because the growth rate, which is our a value, is 3 versus 2. Now let's consider some functions where our a value is less than 1. So where we're going to have some values where we'll have some decay functions. F of x equals 1/2 x, and g of x equals 1/3 to the x power. Fill in the following tables. Okay, looking at f of x, I'm going to do these over to here, this side. So when x is negative 3, we get 1/2 to the negative 3 power. Well, that's going to be the same thing. Whenever you have a negative exponent and you have a fraction, what you can do is you can do the reciprocal of the fraction, which the reciprocal of 1/2 would be 2 over 1, or just 2. And then you can make the exponent positive. So that's the same thing as 2 cubed, which is 8. 1/2 to the negative 2 is the same thing as the reciprocal of 1/2, which is 2, and then positive of that exponent, which is positive 2, so we get 4. 1/2 to the negative 1 is the same thing as 2 to the 1 power, which is 2. 1/2 to the 0 power, anything to the 0 power is always 1. 1/2 to the 1 is 1/2. And then 1/2 squared is the same thing as 1 squared over 2 squared, which is 1/4. I'm going to actually graph this one in blue since I underlined it in blue. So we get -3/8, -2/4, -1/2, 0/1, 1/1/2, 2/1/4. Okay, doing g of x, which is 1/3 to the x. So I'm going to do this over on this side. Do it in green. So 1/3 to the -3 is the same thing as the reciprocal of 1/3, which is 3, to the 3rd power, which is 27. 1/3 to the -2 is 3 to the +2, which is 9. 1/3 to the -1 is 3 to the +1, which is 3. 1/3 to the 0 power is 1. 1/3 to the 1st power is 1/3. And 1/3 squared is 1 squared over 3 squared, which is 1/9. So when we go to graph this, we're going to have a point way up there. -2 is at 9. -1 is at 3. We're still sharing that same point in common. Notice that on the graphs on the other side, they both had this point 0, 1 was on both of those graphs as well. And then 1/1/3. Okay. Can y equal 0? In this case, the same thing. No, y cannot equal 0. And again, that's because you can never put something, a number, to a power and get 0. Why do these functions decrease when the graphs in the last side increased? So notice that these are decreasing because as your x's are getting larger, you can see that our y values are actually getting smaller. And the reason for that is because we actually have a decay factor. We have a is smaller than 1. So what this is doing is every time we're moving from one x value to the next, our graph is getting smaller because we would take 8, multiply that by 1/2, and you get 4. 4 multiplied by 1/2 gives you 2. 2 multiplied by 1/2 gives you 1. So we're multiplying these numbers by a value that's less than 1, which is in turn going to give us a smaller value. Let's talk about these characteristics of this graph, these graphs kind of in general. So graphs, f of x equals a to the x, where a is larger than 0, it can't equal 1. These all have the same characteristics. They all have a horizontal asymptote, and that's at y equals 0. Again, y can never equal 0 for these functions. We'll get very, very close, but we'll never be able to equal 0. The domain for all of these functions is all real numbers, or from -infinity to infinity. The range for these functions are from 0 to infinity, not including 0. The x-intercept. So there is no x-intercept. We never can cross the x-axis because that would mean we had a y value of 0. The y-intercept. On all of these graphs, we had a y-intercept of 0, 1. These are all increasing if your a is larger than 1, and they're all decreasing if your a is between 0 and 1. Any graph of this form is always going to contain these points. 0, 1, 1a, and -1, 1 over a. Go ahead and pause this video, and what I would do is go back to the last 2 slides and make sure that when we were looking at those graphs of y equals 2 to the x, that the point 1, 2 was on that graph, and -1, 1/2 was on that graph because this had an a value of 2. Go back and look at the graph of y equals 3 to the x. That should have 1, 3 on that graph, and -1, 1/3 on that graph. And then vice versa, looking at the graphs that we just did on the last slide, the same type of thing should happen. So these 3 points will always be on those graphs. So remember, if your a value is larger than 1, it's increasing. So these graphs will look like this. And if your A is between 0 and 1, will be decreasing. So those will look like this. It'll contain those shapes. Now let's graph a function. So if I were asked to graph f of x equals 3 times 2 to the x minus 1 using transformations, determine the domain, range, and horizontal asymptote. Okay, so the big thing is if you go back to our transformation section, it's remembering we have to first figure out what's our parent graph, and then we write down what the transformations are that our function is going to go through. So we can see that our parent function is going to be 2 to the x. That's the basic. So again, in exponential functions, it's always going to be a to the x. So it's whatever that base is to the x is what you start with, and then we're going to be transforming that. So first we would start with 2 to the x. And then we're going to take that graph and we're going to do a vertical stretch of 3. Which is going to multiply your y values by 3. And then we're going to shift it down 1. Try your y values minus 1. Okay, so we can either do a table of values or we can kind of look at what this original graph of 2 to the x would look like and then make it, have it go through those transformations. It's up to you. I'll do my points and then kind of transform those. So we just learned on that last slide that all exponential functions in this form are going to contain the points 0, 1, 1a, and negative 1, 1 over a. So that means if I'm starting out with that first thing where we've got y equals 2 to the x, we know those points that I'd start out with would be 0, 1, 1, 2, and negative 1, 1 half. And those are the points I'm going to transform. So I'm going to take them, and the other thing to take into account is the horizontal asymptote, and we'll transform that as well. So the horizontal asymptote we learned on that last slide is always y equals 0 for anything as a to the x, but we're going to have to transform that to get to this graph. Okay, so step 2 is a vertical shift, so that was multiplying our y values by 3. So that becomes 0, 3, 1, 6, negative 1, 3 halves, or 1 and a half. I'll actually write it as 1 and a half because that's a little bit easier to see where that goes. And then our horizontal asymptote, do the same thing there. So that's a y value, so that'll get multiplied by 3, and 3 times 0 is just 0. Now I'll take my y values and do step 3, which is subtracting 1. So I get 0, 2, 1, 5, negative 1, 1 half. And when I take from my horizontal asymptote and shift that down 1, that becomes y equals negative 1. So now I can graph this, draw my asymptote. Okay, so these are my main points on this graph. So 0, 2, 1, 5, and negative 1, 1 half. You have to go all the way down to that horizontal asymptote. And there you go, there's your sketch.